see if I can give you a suggestion there. So it really is just one finger. So if you take this and literally set it around your fingers, it helps you keep that.
Secret.
Size this one.
So one
Same answer.
Yeah, because like.
I almost want to say that seems to have to see the most consistent crystal growth.
Because it's kind of that's just philosophical.
Yeah.
Yeah. I'd say that having it rest on your finger, that's still better than stabilizing. I should like make an adapter.
Yeah, that'd be cool.
This helps you not let it move, but there is a way to do it.
Yeah. Those, if the admirals put up the seas at the.
Oh, I think
Potential. We could say that. Say no. Choose to. Dig deep.
I'm not wrong. I guess I'll pick it up.
For a minute. I figured if you look at both of them, because of both of them,
Well, that's what's left of it. Do you want us to add this to?
No, any residue like that, you can just put to the drain, just rinse with water. It's safe to do that.
that would go long.
Looks like
Good thing I wrote this. Do you have that sheet back yet?
the composition sheet.
Yes.
Well, let's see where we get to.
I may have.
Okay, we'll pass that on over.
I already wrote it in, but I think I wrote these two shirts.
Okay. Well, yeah. Correct it with,
I need to correct that.
correct it with the right numbers, and then we'll proceed.
Alright, so we just rip this out of here.
Yeah, you can actually.
So, yeah, when you take it apart to make the report, you could just leave that part out, or there are a couple of these, like this one is up front here, like these two, and the chromium ones, you could just go based on your own or that giant sea crystal I've got. So all it is really just sketching, is just discussing different shapes.
Okay.
So in theory, you can do that with examples up here. So like these two right here. And you can just kind of talk about the fact there's no right angles in a copper crystal. It's not a cubic system. Thank you.
So we can do the first three.
Yeah, so you could just make a few observations. That way it's not a total wash. All right, so then I guess this needs to continue on around.
It was from my dad's old telescope, and it has a Shade 13 solar filter on it. Well, shade is basically just how dark it is.
Yeah, there's an interesting crossover between welding and astrophysics with these solar lenses. I've played around with those a little bit. Otherwise, you really mess up your eyes. So she said, so you're into telescopes?
I have my dad's old telescope, and it's actually powerful enough to see the rings of Jupiter.
Nice. Jupiter.
Mhm.
That's
Or not Jupiter, Saturn.
Saturn. Okay. I
Yeah.
was gonna say.
It's that powerful.
Yeah.
I was gonna say Jupiter, even though it has a few rings, they're not that big.
No, I was like, you can see that with your telescope? That's awesome. That must be an insane telescope.
He inherited the Hubble.
Right. I was gonna say I didn't know you could do that with normal land-based telescope.
Could we find that song? Probably not.
Yeah.
It's blue.
I would say
He said there's no red angles.
See, is it? I think they did it for some.
That thing goes over there. Unless he just wants the good ones, yeah.
They're also addition rates. If it was all the same addition rate, then you could start calculating like your gradient is like inside was a little colder because of the location of the outside downdraft. Click it on. I started trying to figure it out basically. But it says you really have
Upper microscope in there.
Anything else?
Oh, yes, that was.
So it's not necessarily like this jumping off. Great. So what this is going to the number of carbons increases the non-polarity of the alcohol. This makes it harder for that to drill down into the water. So
We just been all three things.
That's all.
Or did you write the colors?
Result in more of a shock.
No, this is just.
Ours definitely good.
I still think we did. Yeah, doesn't even look like there's a single gravity. Those two. I'd say that's It's crazy that you can't even hardly feel it.
Yeah. I feel like I'm one of the more summer.
So once you get your observations done, don't know which bin they go. Yeah, if you're getting mixed in the
Actually, I would
separated, put them there and there. So let's take another 5 minutes or so, and then we'll transition to the glass part of the lab. You make sure that composition sheet makes it all the way around, so we'll know what we're pouring. Someone's really glad to help.
Yeah.
No, it all.
Hello.
We did the field observation.
Do you remember which one?
No black.
Yeah, so well.
Yeah.
So I'll make sure to make a. So, you know, section 1 is normal. So somebody's canceling extra time.
It's like she'll leave tonight and I start.
I don't know what he does other stuff.
Great. Yeah, that's tricky though, because
How many people said no?
students have paid for that time. So if he's blocking the class,
Because
another
thing.
make that up. Because it's kind of like contract. You guys have paid for a number of hours.
That's how many videos.
Yes.
There's like.
Well, then I guess he's kind of. Hey, whatever. That's no, so those, since they're nice, you can just put in the alternate experiment bin up there.
Sure you need to.
So it's up there on a row that's kind of towards where I usually stay.
It says,
Projection.
That's
the natural color.
Yeah. You see where it's at. Oh, yeah? So then you're.
Yeah, at least for us.
Yeah, what I like about that is what we do, it's pretty cool, but it's just so small.
Yeah.
For sure.
Yeah,
I feel like
one crucible compared to a tank is twice the size of the that's 40 feet, full tons of molten glass.
One thing we do,
Yep.
great lunch.
And anything, any solid residue that's left over, you said you
Yeah.
just rinse down the drain.
Put that in your
deal with it.
I was like, why? And then I went back home and I was like, oh, I remember now.
Yeah, we'll actually, I actually don't have to, I don't know if you looked at this. Rules was, but that's one of the rules. No tobacco or liquid.
Yeah.
And so I'll be specifically mentioning that. Make sure that that gets in the batch, it's sometimes 2 weeks worth of production. One little can screws up that 2 football fields worth of production for 2 weeks. So, they said it's happening all the time. That is hilarious. It's like just the sound of that pop sound. Everybody. Joe, you're fired. So I do have one more composition, R9. R9. Anybody have R9? Did you guys? No? R9? But you guys? Okay, so we'll have you put your composition in there, and then we'll have the full batch set. So whatever the variables are from last week, you just, yeah, like 8, 7, just kind of tabulate that one in there.
I know. I was kind of
Just a technique.
yeah.
Yeah,
I did remember.
Still like, it's way bad.
I spent all of Tuesday doing research from work. Completely forgot about it. It was like 10 o'clock at night.
So we'll start talking about the glass here, and so just finish up what you're doing with the crystals. We'll come back to it. But to facilitate the process up here, we'll need a few volunteers. The cool thing about that is you get to see things up close and personal. A couple of them are more like on standby type jobs, like for instance, the first one. I do need a fireman or someone to stand here by the fire extinguisher. And in the event that something crazy happens, you're ready to douse whatever happens. And so they often don't want students touching fire extinguishers. Or that's you? You volunteer?
I am volunteering.
Okay. They often say, we don't want students messing with fire extinguishers because we just want them to exit the building in case of a fire. I'm like, what if the fire is blocking the exit? No, we just want people to leave the building and not fight the fire. And so they're like a broken record on that because they don't want to give fire extinguisher training. It's really complex. It's the word pass. You pull the pin, you aim at the bottom of the flame, you squeeze the lever, and sweep side to side. There you go. Fire extinguisher training. Don't aim at the flame, aim at the base. Not the flame, the base. And squeeze and sweep. Pull, aim, squeeze, and sweep. That I've had fire extinguisher training several times. That's what they say. So you've been trained. But yeah, that one just kind of makes their heads explode when I'm like, what if the fire is blocking the exit? I don't know. I've got issues with things like fire panel or electrical panels and fire extinguishers. They used to have, I think, 2 or 3 in every lab. But then they came through and said, no, the regulations have changed. You only need to be within, I think, 50 feet or 50 yards or something of the nearest fire extinguisher in the building. So ours is out in the hall. And that way it's easier to maintain, fewer to service, fewer to have inspected. But usually they had them bolted the wall next to every few hoods, not here, but in grad school. So they took all the fire. I've never really had to use one. But it's nice to know they're there. So it's another one of my pet issues, I guess. So we've got our firemen, thank you. So next up is a torch. So what that entails is I'm going to bring it over, a propane torch. And so the propane torch allows us to keep the glass hot while it's being poured. And so what you'll do is a slow pull. If you go too quick, it doesn't ignite properly, but a slow pull. And you'll just hold the bright tips of the brighter blue flame. You'll hold right next to the pouring finger or bead of glass that's coming out of the crucible. And that way it keeps it hot and prevents it from making lots of fiberglass. And so we'll show you how to do that. But anybody have experience with torch, plumbing, doing solder work? Anybody? You take your up close and personal with all this action. It's awesome. No volunteers? Yeah? Okay, thanks. So it's not really that hazardous. So I've never had anybody get hurt in this lab. So a previous professor though did. He hurt himself. He got a piece of fiberglass in his finger. But I'm pretty careful. So all right, next up, easy job, coordinator. So I've got a firing diagram here that shows the way that the furnace is loaded. And I've also got a batch record. And so I'll be commenting on the composition as we go so we can know what to expect. So it's like a lot of people, quite a few people also had a fairly straight 90, 50, 25, but we've got some nice deviations here too. We've got a high flux, we've got a super low flux. What that's going to do. And I've also got some unique color mixes, and so we'll call out what to expect as we go. And so I'll need a coordinator to help as I pull. I usually go center, left, right, as we unload the furnace. So anybody want to help coordinate, stand here and help me with coordinating that? Anybody at all? Volunteers? Has volunteerism died now? Anybody? Going once? Maybe if I started paying people, it would help. Thank you.
I've got 3 dimes. Let's start there.
We'll start a GoFundMe page for the glass jobs. This one's a cool job. The stamp. So we've got all these different compositions, and so we'll be taking, for instance, N9 with a metal stamp, and so your job is to wait until it gets to a slight orange color. You don't want to go right at the beginning, otherwise it obscures the stamp because it melts back in. But you let it go to sort of a dark orange, and then you stamp that piece of glass with the stamp. So if this is the disc of the glass, you just sort of make an impression right there at the bottom. And so this one will be N9. The tricky thing about this is that it needs to be backwards when you're looking at it. So I often just sort of press it on my skin a little bit, and you'll be able to see a shadowy impression of what it will look like in the stamp. And so anybody want to do the stamp work, you get to stamp molten glass. Resume material right there. All right, thank you. So you can hang out over here once we get rolling, and I'll call the stamp. The 9 stays the same. You just keep swapping out the number. And once I move the crucible to the side, you can walk in or walk around, and then I'll try to help you calibrate the trigger point of when to stamp. But you just sort of move in quick. If you need gloves, we'll get you gloves. The heat can be intense, but there's ways to work around that. So one other job, that's the door. This door is a clamshell, double clamshell door, and so it's counterweighted. So the first half of the arc opens up the bottom of the clamshell, and then there's a pause, and then second half of the arc opens up the top. There's a refractory brick that is brittle in the door. And so if someone were to go too quick and slam through that transition, it's going to jar the door. And I have had little chunks of the brick that are very hot go flying everywhere. But if it's just smooth to center and then smooth on down, I'll pull the crucible and then smooth to center, smooth on down. That's the job. It's an important job. Anybody want to do the door work? Oh, we got you thinking about it. You good? Okay, that's the full set. So yes, we made it again. I don't have to draft anybody. So I get to wear a shiny suit. So that's lurking about in here. And I've got an extra set of gloves here in case you need them. Sometimes the torch work gets a little bit toasty, but so you can sort of get where you can see. The table will be recorded, so this area right here will get recorded so we can review that later and see the differences in viscosity during the pour. And so I'd probably say back up a little bit, give us about a 6. You don't necessarily have to hold, just kind of beat by. But give us a good radius here for working. When glass does break, make sure you do have your goggles on. But the way that it breaks is it typically shatters outward. So it's not like a true grenade going off. It's tension in the glass that releases. So it often will shoot straight out and then take a parabolic arc down. And so it's pretty unlikely that it's going to get in your face, but it often can shoot to the side. That usually doesn't happen until about 20 minutes after the pour, and I can usually tell right after I pour it if it's going to do it. So, but not always. It's a mystery. So, all right. So this is from last time. So first up, we have L9. So let me see the composition sheet a little bit. Talk about L9. So this is a straight cobalt glass. Straight run viscosity too, 90, 50, 25. So that'll be a good starting point because the viscosity will be in the middle of the road. All right, so go ahead and get to the position on the door and torch. Usually you can straight the torch right after I pull from the furnace. And then I'm going to start pouring right here. And I'm just going to, so the torch usually, it's best to stand back here. And I'll just pour 3 sets of 3, probably 9 here, and then 3 down the side right there. And this is where the crucible will stack. So you'll just sort of come in from the side with the lit torch and just heat the bead of glass as it leaves the crucible. So that's the idea. All right, so we're pulling L9 from the middle. A little closer, you're going to want the blue part of the flame to be real close to the bead of glass. Good. And then heat the part where the glass just came off until it flattens in. All right, so then the stamp, get ready. It's not quite there yet, but right about there, you'll want to stamp. It's all right. You can stamp it. Go ahead and press it in. Bottom edge there. That's good. Yep. Cobalt's the worst for radiant heat because it's so dark. It actually is very effective at radiating the heat. I find that putting on a rubber glove does help a little bit if you want. Otherwise, it's just kind of a quick and move away there. So that's the way it's going to go. With the torch, one thing that I found is about the best posture is to angle it about like this. That way you can get in close and kind of protect your hand from the heat. But if you need a glove, I've got some gloves over there for if and when you feel so inclined. It's about 50-50. Sometimes people do, sometimes people don't. All right, so the next one's going right behind it. So right there, that's a nice dark blue glass there. So we're pulling from the left. So this is a lower flux, 90, 40, 25. So we'll see what 10 grams less sodium flux does. Watch the diameter after the pour, and also watch the thickness of the bead of glass. It should change. And this is a half-load chromium glass, right? So
Yes.
M9 is our composition. All right, so let's go for that. Go ahead. That's not good.
Is it gonna break?
Yep. All right, I hit that string there. Oh, and work on that string on the edge. So heat on that side to make the string melt. Over here on the side. There you go. Keep hitting that. Keep hitting it. All right. Finish that. So then you can move in and stamp it now. It'll once it gets brittle, it'll break off. Okay. Now that looked like it had a little bit of unmelted batch. So unfortunately, that one's going to blow up. Now, the good news is that we have probably about 20 minutes or so. But
Oh, that's scary.
well, all I have to do is just put a beaker on it, or I could even go ahead and move it back. That sometimes gives it thermal shock right at the beginning. But any defect like that just has a way of making places where the tension isn't shared along the crystal lattice, or not the crystal, the amorphous
Structure.
bonding structure. Makes a weak point. So as the tension loads up as it cools, it focuses that and causes it to break. So what that often is caused by is a chunk of flux that doesn't get completely broken up when you stir it. I think that happened last time too. So it does happen. I'd say about one out of every group. These things happen, so we'll still be able to collect the color, and it'll probably break that side off. So.
Should we get a beaker?
I guess I'll go grab a beaker quick. So I'm not going to cover it quite yet, though. We'll have that for later. All right. Next up, we've got N9. So this is a straight run 90-50-25 for viscosity. So standard batch. And it's no color. Is that right? 09.
Oh, and
Oh, N9. I'm sorry. We've got 0.2 for chrome, 0.5 for copper. So chrome copper. N9. So pulling from the right place. All right. Chrome copper. Go ahead and really melt that in. Looks good. Okay, that's good. Piece just flew there. These will stay hot for quite some time, so do be careful. What you're hearing, starting to hear, is called crazing. The ceramic has a different coefficient of thermal expansion than the glass. So as the glass is shrinking as it cools, and so is the ceramic, it puts tension on the thin layer of glass. And every time you hear that little, tinkling cymbal there, that sound, it's a new crack forming in the piece of glass. These are already completely crazed in the little checkerboard pieces you can see, and these are on their way to getting there. So crazing is what that is called. I think I might go ahead and move this piece back. It's probably, it could shatter as I move it, but we'll see how lucky I feel. I give that a pretty high probability that it's going to crack. 85% chance. 89.6% chance. So it's just the way it is sometimes. All right, so we'll re-pour that one. So, or a different one in that spot. So next up is 09, and this one is essentially I see what it is. We've got a low sodium, high calcium, right? That's what you guys did. So it's clear, so no color, clear glass. So, all right. So then really hit that bead to heat it up and make that pull in. That looks good. Okay, go ahead and stand it. Yeah, nice and clear, and you can see it does have a smaller diameter by a little bit. So we'll see how that pans out. Yeah, I was looking for, I guess he's hanging out back there, hiding behind the camera. I'm like, this is your glass, man.
Yeah, I filmed it.
Okay. That's why I was looking at you funny. So, okay. So that was O. Next up, we've got P9. So this one is a little high on sodium, a little 5 grams higher on calcium.
Oop, there it went.
There it went.
Ooh.
That's what I told you. Yeah. Aren't you glad I put that beaker on there?
Very.
Now, the neat thing about it, though, is that it's not a total loss. This now is called cullet. It's crushed glass, and you could remelt that, and we'll still be able to get color observations, but we probably won't be getting any diameter observations. I should have measured that already. But we'll still put that in a beaker, and that way we can still do the color part of the observations. So, all right.
Oh, we missed it on film.
Oh, the breakage. Yeah. Sorry.
People at home will know what happened.
Yeah, they'll know. I don't think we've got any yet. Yeah, nobody's currently watching. I'm mostly just capturing. I didn't announce this one. I'm just trying to capture it so we can review it later. So it hasn't gone viral yet, but just wait. I'm thinking here in a few minutes, it's really going to pick up. Okay. P9 is a copper manganese, so purple and blue, right? So I'm pulling from left side. So we'll pour this one right there. Okay. Ooh, we can lower viscosity for sure. See how easy that poured out?
Mm-hmm.
Look how thin the bead is.
Making me thirsty.
Oh yeah? That's like the Grinch, right? He eats broken glass. I don't know about molten glass. Yeah, that behaved a little different than I expected.
That's upside down.
Well, we'll figure it out. I'll put a typical label on there as well eventually to make it easier to read. There's also some interesting behavior of hot glass and color. And that is the color during the cooling process sometimes changes. It's called the striking of the glass, or the striking of the color. At what temperature does the color strike at? So what happens is, if you first pour it, it might look black or brown. It then transitions maybe at 600 degrees or so, 700 degrees to a different color, like chrome does this. It goes through a dark brown and then a bright green. So some glasses exhibit some unusual color behavior. My glove's starting to come apart. That's interesting. But we'll see. So that's a copper mirror of reduced copper from the torch. And when we pick that up later or put it on the light table, you'll be able to see through it and see a different color than the copper. But it's carbon monoxide in the flame pulling electrons from the copper and reducing a little bit of metallic particulate copper is what that copper mirror is that you see on the glass. Kind of a unique thing for anything that contains the copper in it. All right. So next up we have Q9. So this is a high calcium, and it's a copper manganese again. So was that a match pair?
No.
No? Okay, it just happened to be that way?
happened to be that way.
Because we did have some groups that collaborated. So this should be similar to the previous one, but much lighter in color. So that'll be a nice contrast. We'll see what a lower copper load will do. So we'll pour that one right there. Great. So far that looks like a grayish, more grayish blue, purplish blue. Interesting color pair there. This one I think is going to transition a little bit the color. If you look at that rim right there, we'll see how it changes over time. All right, it's progress. So next up we've got R9. So that looks like a straight for silica, sodium, and calcium. And then it's an iron manganese, high iron manganese. So I've tried that before. Next week when we go to Cardinal Glass, they'll talk about rouge. Iron oxide, they call it rouge. It's how much iron oxide they add to the batch. That's what makes normal window pane glass. If you ever looked on the edge, you'll see a little bit of a green color. You ever noticed how if you look on the edge, it looks kind of green, but it looks clear this way. What that does is twofold. Number one, it makes the heat distribute a little more evenly in the furnace. Number two, it makes the glass in the window more UV resistant. The iron does a very good job of absorbing ultraviolet. So that way it's better for our eyes indoors because we don't have UV light. But for instance, Cardinal Glass during the 2008 slowdown economically, they transitioned to a clear glass with no iron, super clear glass for solar panels. Because in that case, they do want the UV to get through to their collection, energy collection. So they ran a low iron glass for that purpose. All right, so I am forgetting where I'm at here. So S will be a iron glass. No, I was about to pour R, wasn't I?
Yeah,
R, yes. Middle. Talking about iron. Close to each other. They're stuck on each other now. I guess it is Valentine's Day. I'm stuck on you, literally. Isn't it sweet?
Well, as a droid once said, if you watch Star Wars 2 Attack of the Clones, where the battle droid's head gets welded onto C-3PO's body,
Okay.
it says, uh-oh.
Okay, I'm stuck on you.
that's
Okay.
one with the.
Yeah. I haven't seen that part. I've seen lots of the older ones, though. Must be one of the newer ones.
Yeah, it's one of the prequels.
Prequels. All right, so next up we have composition S, which is somewhat similar, except this one does have far less iron. It's iron only. So this will be a kind of a light iron color. So we'll pour that guy right here. I'm pulling from back left. My glove smoking.
Yeah.
Get toasted? Yeah, feel free to use one of those white gloves over there if you'd like. Come on.
Do we need another pair of tongs?
No, it just is a matter of getting to the right temperature before it breaks, and then you gotta break off the piece. It's just some glass is a little more elastic, different temperatures. Trying to get that too close to the rearrangement there. So, all right. Just move a little bit. Next up is T9. This is a chrome chrome copper, and this might be one in a set. Maybe it looks like it might have coordinated. Chrome copper T and U, 0.3, 0.04, and then 0.5 and 1. So fairly low chrome copper. Got several of these, so we'll be able to do a nice comparison there. Anyway, this is T9. So the purpose of the torch, as you probably know, but I'm going to reiterate, is to try to eliminate as much of that fiberglass as you can, because the fiberglass is the most likely thing to get stuck in your finger or have some problem with. So that way we can handle this once it cools and be relatively safe. I have had one of these things blow up in my hand before.
Really?
Yeah, it's surprising. When I was holding it kind of hurt the inside of my knuckles. It was kind of like I got mildly hit with a hammer on the inside of my knuckles. I was holding it like this, and it was like shattered. So it was a unique experience. It didn't really do anything except hurt my knuckles. But these things can blow up randomly up to a year later. I had one go off a year later, just sitting in a cabinet. What was that? Open the door, glass everywhere. So they're unpredictable.
Cranky.
Yeah. All right, we've got 3 more. U9 is next. Go ahead. All right, so we got 2 more to go. So we'll put those back piece. Back a little bit. Sweep up a little bit of that glass. Catch the candle here on fire. We'll see. How you feeling? Sure enough.
There's smell.
Yeah, that's the burn. It's burning in the hair. Yeah, I used to take a little bit of water and put a little dot of water on this so you can see how it's boiling. You could cook on this. This is about like a stovetop right now. But a little droplet of water hit one of the pieces of glass and cooled a little spot in the center, and it just shatters, goes off. So I don't do that anymore. I just burn camel hair on it. It's awesome. So we'll pour one right there and one right there for the final 2. Should probably adjust my angles. That'll work. So V and W, just like the car. Main. So we'll say for this last one, it's a little bit trickier with the torch. Try not to get the torch on the already cooled glass. That can do bad things. It wasn't enough that time to create any problems, but this last one's going to be tricky. So I'd say try to angle it towards this one that we just made and not towards the others. And that one, forget to call, what was the composition? That one was high flux and only manganese. And it does look noticeably bigger in diameter, so that translates to the high flux, so you'll be able to measure that later on. One more. And this one is normal viscosity or diameter, and another chrome copper. That was popular this time. Wow. Chrome copper, last one. So get around that little button that just came out. There you go. That looks good. Yep. Great. Way died. Congratulations. So at this point, we've got a little bit of time to wait. So I'd say go back and you can finish up your crystals, and then I will prep the, well, that's nice to save. Very good. But I'll prep the videos so we can watch those. So we'll move on to the next part. Thank you for your help, for those that helped out.
At least we didn't have to call Station 51.
Yeah. Didn't have to call any fires in it. Triage. Yeah, you can set that there. So the crystals can go into their respective seats over there on the far bench.
If you were to do the problem experiment over again, what would you change?